You see that you would have studied about graphs in lines chapter. You would have studied that how a two variable equation can be written on an xy plane. Similarly, a graph in this chapter shall remain a two-dimensional plane in which there will be two axes, one will be x-axis and one will be y-axis. We will almost always call the horizontal one as x-axis and the vertical one as y-axis. The intersection of these two axes shall be called origin. Now this is a graph. You can see that there is an x-axis, there is a y-axis, and then the intersection of these two axes is called origin. These two axes have two different variables associated with them. These variables with x and y need not to be same, may be different. So what we are doing in fact is that we are studying the relationship between these two variables on graph. Now in a graph there is always given a scale. A scale tells us that how much when we move on x-axis the real data moves in real life. Similarly, there shall be a different scale for y-axis, that how when we move on y-axis how the real life data will move in the real life situation. Now this is an example of a graph question. Now in this problem what we have been asked is that a certain person is going from his home to school. The home is at the origins and he is going through this given path towards his school. The two axes, x and y axis, both show distance in miles. However, the scale on x-axis says that 1 unit equals to 1 mile, while on y-axis it says that 1 unit equals to 2 miles. The scales need not to be the same. Scales can vary for both x and y-axis variables. Now, if you want to know what is the distance between home and school, how we are going to solve this? What we are going to do is that we are going to find out that how much this person traveled on x-axis, how much units he traveled on x-axis, and then we will multiply it with scale, x-axis scale. So you see that the red lines here are when he traveled parallel to x-axis, and there are total 3 units he traveled towards x-axis. Now these 3 units means 3 miles, because 1 unit on x-axis means 1 mile, so 3 units then shall mean 3 miles. Similarly, we can find out how much distance he traveled in real life on y-axis. On the y-axis you can see that these black lines in fact are shown how much he moved towards y-axis. There are these lines, 2 units he moved towards y-axis, and each unit on y-axis as per the scale tells us that equals to 2 miles. So 2 units means 2 multiplied by 2, that is 4 miles. So the total distance from home to school is 7 miles. So now this problem you can understand what a graph is. A graph is again a two-dimensional structure in which the two variables we are studying, and we just like the equations tells us about some real life story, similarly the graphs are telling us a similar given life story. Now let's study about the next kind of graphs. The graphs can also be said as charts. Now this is an example of a circle chart. Circle charts are also called as pie charts. Now you will study the two-way tables. Now this is an example of a two-way table of how Tina is consuming different kind of macronutrients of food. Now she's on a keto diet, and you're gonna see that of the total 100% calories that she is taking, 5% is from carbs, fat is coming from 70%, and protein is 25%. So now in absolute values of the calories has also been given us. Now if we want to draw from this two-way table a pie chart, how we are going to do? In fact, what we have to ensure is that the total area of the circle equals to 100%. So once given have been the 100% equals to the total area of the circle, then 70% equivalent to the 70% shall represent fat, 5% shall represent carbs, and then 25% shall represent protein. So this is how you can draw a pie chart for consumption of Tina in calorie percentage. In absolute values, Similarly, you can draw another pie chart, something like this. In the pie charts, you see that we have been given a relationship of whole with the parts. There are different parts of the whole. We have been given the information about the whole, and then we have been given about the information of the parts. These different slices of this circle are different parts. So the relationship between whole and a part is given in a pie chart, and different kind of problems may be asked on a pie chart. Now, the next very common chart type that is asked in SAT exam is bar charts. Now, the bar charts are similarly having two axes. There is an x-axis and there is a y-axis. Towards the x-axis, there is a kind of category, there is a kind of a variable that we want to study, while on the y-axis, there's given a certain other value, that measured value that we want to study. However, you can see that there are different rectangles in vertical direction in this case. Now, these vertical rectangles are rectangular bars, and that's why this graph is called bar graph. Now, these bars must be proportional to the measured value that we are studying. Now, let's study this with an example. Now, this is an example of a bar chart, and this is the profit generated by 4 firms A, B, C, D in year 2020. Now, you see that towards the x-axis we have been given those category. That is, category is the number of firms, that is A and B and C and D, and towards the y-axis we have been given that how much the firms A, B, C and D are earning. From this, you can see that you must know that how a graph is studied. A graph is read that from this graph you can see that firm A is earning 20 million USD's profit in year 2020. Similarly, firm B is earning 25, firm C is earning 10, and firm D then is earning 17.5 million US dollars. Now, once you know this information can also be written in a two-way table. Then you can solve almost all the problems. The problems, for example, may be asked that which firm earned the maximum profit. Now, once you know how to read this graph, it's very simple that you're going to say that the firm B earned maximum profit in year 2020, and that was equals to 25 million USD. Similarly, the problem may be asked that which firm earned least profit. Then you can see from the graph again that the firm C earned only $10 million, and it is the least among the four. So the firm C earned minimum profit in year 2020. Now, another question can be asked that by what percentage is the profit of firm D more than that of firm C in year 2020? Now, again, this is also a very simple problem of percentage. What all you have to do, use the formula of percentage, that is profit of firm D minus profit of firm C divided by profit of firm C multiplied by 100. So that comes out to be 17.5 minus 10 divided by 10 multiplied by 100, or it comes out to be your 75%. So that is in fact the problems that can be asked. Now, there is no necessity that these rectangular bars has to be vertical. They can be horizontal position as well. Now, this is the same graph. If the same bar chart, if would have been instead of vertical bars would have been constructed in horizontal bars, then it would look like this. Now you see that both of these two bar charts, whether vertical or horizontal, conveys the same information. There is no difference whether you have kept the bars vertical or you have kept the bars horizontal. Similarly, like bar graph, there is this advanced version of this bar chart called double bar chart. Now, in the double bar chart, we will understand it through again an example. Now, a market researcher analyzes the revenue generation of 3 laptop models in 2 successive years, 2019 and 2020, as above. Now you see that this is a horizontal bar chart and this is a double horizontal bar chart. The dark ones are representing the data of 2019, while the light ones are representing the data of 2020. Now, different kind of problems may be asked from this data. Now, the problem, for example, asked is that for which model growth percentage has been highest over the 2 years. So what you have to do is that you have to find out the growth percentage for model A, then model B, and then model C, and then which one has the higher number shall be our answer. So we can, once you know how to read the data, there's very simple thing. So we find out that for model A, the growth percentage equals to final minus initial divided by initial multiplied by 100. So the final data, that is the data of 2020, is from this graph you can see equals to 200. So 200 minus 150 divided by 150 multiplied by 100. So it comes out to be 50 by 150 multiplied by 100, or equals to 33%. Similarly, for model B, we can find out applying the same formula, that's final minus initial divided by initial multiplied by 100, comes out to be 500 minus 400 divided by 400 multiplied by 100, comes out to be your 100 by 400 multiplied by 100, that is 25%. For the C, you just can see from the graph, you can see that there was no growth, in fact it was decay. So the growth percentage was a negative. So you need not to find the growth percentage for C. You can simply say that you can compare between A and B. For A it is 33%, for B it is 25%. So the answer shall be A. Now, very similar to bar charts are histograms. So this is an example of a histogram. Let us study also histograms through an example. Now, for 120 students of a class in a school, a study was conducted to find out how many average time they spent on outdoor sports on daily basis. Now this is our histogram. In histogram, you can say is very similar to our bar chart. The only difference is that while on the x-axis, while on any one axis, there was given the categories, they were non-numerical value categories. There was either the name of the firms was given or the model name was given. However, in which we have been given a range. Now from this data, you can see that the total number towards the x-axis is the total number of time spent by students in outdoor sports in minutes. And on the y-axis, we have been given the total number of students. So from this, you can see that total number of students who spent time from 0 to 20 minutes equals to 20. Similarly, from 20 to 40 minutes is 35 students, and so on. Now the problem, for example, may be asked is that what percentage of students spend more than 1 hour in outdoor games? Now, if you can read that how a histogram chart is read, then there is nothing extraordinary in this problem. All you have to find out is all for those data values for which the time spent by students is more than 1 hour, that is equals to 60 minutes. So you're going to see that these last 3 bars in fact have those students who have spent more than 60 minutes on outdoor games. So that is equals to 20 plus 10 plus 5 equals to total 35 number of students. How many total number of students were there under the study? Total number of students were 120. So the percentage then shall come out to be 35 divided by 120 multiplied by 100, or comes out to be equal to 29.16%. So that's how another histogram problem can be solved. Now this is a dot plot graph. Now the dot plot graphs are in fact very similar to bar charts. The only difference is that instead of these rectangular bars, we have dots, and these dots, each dot represent some unit variable. Now this is also an example of our dot plot graph. For example, this dot plot graph represents the total number of cars that were sold by a car dealership in 7 days of a week. So you're going to see that on the day 1 there are total 3 dots, and so it means that the total 3 number of cars were sold by the car dealership on day 1. Then on day 2, 4, day 3 and 4 there are 1 dots only, so one car was sold. On day 5 6 cars were sold because there are 6 dots. Similarly, on 6th day 2 dots, that is 2 cars were sold, and on 7th day 4 cars were sold. Different problems similarly can be asked. For example, you may be asked that on which day maximum number of cars were sold. Similarly, you can be asked that what was the average number of cars sold throughout the week. So different kind of problems can be asked on the dot plot graphs as well. All you have to remember that each dot represents unit variable. Just like the bar charts, we can any two-way table can be written on a line chart as well. This is an example of a line chart. Now we will understand it also through an example. Now see that this is a line chart, that is the total number of customers visiting a car dealership has been plotted in a week as this line chart. Towards the x-axis we have been given the number of days of the week, 1, 2, 3, 4, 5, 6, 7, and on the y-axis we have been given the total number of customers who are coming in the car dealership. Now just like the bar chart, different kind of problems may be asked on the line chart as well. In fact, a bar chart can be very easily transferred as a line chart, and similarly a line chart can be very easily modeled as a bar chart. Now for example, from this line chart one may ask that what was the maximum number of customers visited the car dealership. So if you know that if you're going to read this graph, you're going to see that on the 7th day it was the maximum number of visitors came to the car dealership, that was equals to 40. So that's how you can just read the data. Similarly, maybe ask that minimum number of visitors came which day. So you're going to see that on the second day only 15 number of visitors came. So that's how you can read another data. Now another problem may be asked that for how many days the visitors decreased compared to previous days in the week. Now this problem asks us that we study the data of this customers on 2 successive days. So we started on the first day 20 number of customers came, on the second day 15 number of customers came. You see that the number of data has decreased. That's what the problem is asking. The number of visitors decreased compared to the previous day. 15 is less than 20, so this is one day. Second day is one day when the number of visitors decreased. On the number 3, you can see from the graph, from number 3 and 4 it is an increasing curve. On number of 3 it is 25, again number 4 it is 30, so it's on the increasing curve. And then on the number 5 it's 25 number of customers. 25 is less than 30. So on the 5th day number of customers were less than that of the 4th day. So that is again now going to be another day. Then on the 6th day came 30 number of visitors, 30 is greater than 25. Then on the 7th day maximum number of visitors came, that is equals to 40, which is again greater than 30. So the number of days when visitors decreased compared to the previous days is 2. On the second day and on the 5th day of the week number of visitors decreased. So you see that how very easily, there's nothing extraordinary knowledge now you require when you are reading with the graphs. In the graphs, all you have to do is that you have to apply your basic understandings of percentage, basic understanding of arithmetic, and just very basics of all the things that we have studied till now. Similarly, now this is a box plot graph. Very rare, however, SAT also asks you box plot graphs. Box plot graphs are also called box whisker graph. We will also understand this box graph through an example. Now, the example states that a pizza shop owner summarizes the number of pizzas sold in his shop for a period of 1 month using a box and whisker plot as below. Now the box and whisker plot has been drawn to us. Now you say that we have been given towards the x-axis, we have been given that the total number of pizza sold has been given, that there is 10, 20 and go so on to 100. And there is this box and whisker thing has been given to us. This box thing and the whisker thing, you can see that there is in the middle there is this box, and on the two sides, left and right hand sides, there are the two lines. These are called whiskers. Of the left hand line, when I talk about that, the starting point of this left hand line represents the minimum value of this data set. It is the lowest limit of the data set, that is equals to 15. Similarly, of the right hand side whisker, the end point of the right hand side whisker tells us the greatest value of data set, that is equals to 95. So from these two starting and end points of two whiskers, what we have is the lowest value of the data set and the highest value of the data set. What we have is that of the all within this month, minimum number of pizzas sold on any day, we do not know about the date, but was equals to 15. Similarly, the maximum number of pizzas sold was equals to 95. That information we have. So we can also find out what is the range of the data. Range equals to the greatest value minus lowest value equals to 95 minus 15 equals to 80. So you may be asked about the range of the data set in the whisker plot. If that comes out, then you have to find out what is the starting point, what is the end point of the whiskers. Once you have that, range is greatest value minus lowest value. Now, of this box, you can see that there is always be given a line in between the box. This line in the box in fact tells us about the median. So this is a different kind of graph. This kind of graph, there's no name of this graph. However, this another graph. So this graph shows us that about the active COVID-19 patients in a city in year 2021. You see that there's a graph. This graph initially is increasing. That increased towards the highest in August, then it decreases to some extent, then it again increases, and then it's going on to decrease. Question, for example, may be asked that for how many months total COVID active patients in the city were more than 7,000. Now in this problem, you can see that you have to just do is that you have to very basic understanding of how graphs are read. Once you know that towards the y-axis, we have been given the number of COVID active patients. So this, when you draw a line parallel to 7,000, you can see that there are only 3 months for which the number of COVID active patients was more than 7,000. For the rest of all 9 months, the number of COVID active patients is less than 7,000. So for July, August, and then again in November, number of patients is more than 7,000. So the answer for this problem then will be 3. So that's all about charts and graphs. Remember about charts and graphs that there's no additional skill, mathematical skill I have taught you. All what I have told you is that how to read graphs, and you must exercise more and more problems in order to understand that how different datas are given in graphs and how to understand them. So you must go on and solve problems related to graph in order to further accentuate your understanding of graphs.